day Bayaws! Welcome to our YouTube channel Bayaw Tutorial. In this video, we are going to solve a problem from thermodynamics and heat transfer that involves the heat transfer by convection. So here is our problem. A 250 watts heater has a 0.15 meter diameter spherical housing. Result number is equals to 2 plus 0.6 multiplied by Reynolds number raised to the power of 1/2 multiplied by Prandtl number raised to the power of 1/3, with Reynolds number is equals to 10 raised to the power of 5 and the Prandtl number is equals to 0.70, yields the heat transfer coefficient for conduction and convection from the casing to the ambient air. The ambient air temperature is 30 degrees Celsius and the thermal conductivity of air is 0.02 watts per meter Kelvin. Find the heat flux from the surface at steady state and find the steady state surface temperature of the casing. So here in our problem, we are asked to determine or to find the value of the heat flux from the surface at steady state and the value of our surface temperature of the casing. But before that, we need to identify first the given values in this problem. So we have the value for our heat, which is equals to 250 watts. The Nusselt number equation is already given in this problem. The Reynolds number is equals to 10 raised to the power of 5 and the Prandtl number is equals to 0.70. The ambient temperature is equals to 30 degrees Celsius. The thermal conductivity is equals to 0.02 watts per meter Kelvin. And the value of our diameter, which is equals to 0.15 meter. So, solution. Heat flux Q from surface is given by Q is equals to the heat divided by area. So, since the figure here is sphere, the area of sphere is equals to 4 pi r squared. So by plugging in the given values, we have 250 watts divided by 4 times pi multiplied by 0.075 meters squared. The 0.075 meters squared is the value for our radius, since the diameter is 0.15 meter. And by simplifying this equation, we can get the value for our heat flux from surface, which is equals to 3,536.78 watts per square meter. So for the Nusselt number for convection is equals to 2 plus 0.6 times Reynolds number raised to the power of 1/2 times the Prandtl number raised to the power of 1/3. So by substituting the given values, we have 2 plus 0.6 times 100,000 raised to the power of 1/2 times 0.70 raised to the power of 1/3. So we have the 170.46794 or 170.47. So next is the convection heat transfer coefficient, which is equals to Nusselt number times the thermal conductivity of air divided by the diameter. And by plugging in the given values, we have 170.46794 times 0.02 watts per meter Kelvin divided by 0.15 meter is equals to 22.73 watts per square meter Kelvin. Now we have the value for our convection heat transfer coefficient. Next is for the heat transfer by convection, which is equals to H multiplied by the difference of the temperature of the free fluid flow and the temperature. So by plugging in the given values, 3,536.78 watts per square meter is the value for our heat flux is equals to 22.73 watts per square meter Kelvin multiplied by the T minus 30 degrees Celsius. And by simplifying this whole equation, we can now get the value for our temperature, which is equals to 185.3 60 degrees Celsius. So now, the value for our heat flux from the surface at steady state is equals to 3,536.78 watts per meter squared, and the value for our temperature, which is equals to 185.60 degrees Celsius. So that's it. Here is the answer for this problem.